Alright, here is geometry. Last notes for chapter 3, toes 21. It says prove theorems by perpendicular lines. Make sure you put your name, your date, and your class period. The essential question is, how do you find the distance between a point and a line? To find the distance between a point and a line, you need to find the slope of your line and then do the perpendicular slope. And once you find the point on the other line or to the point, use the distance formula. Okay, the distance from a point on the line is the length of the perpendicular segment from the point to the line. So that's where we're going to be messing with the perpendicular slopes. Will be needed. Okay, we do have a couple theorems. Okay, I just changed your theorems so that you have the actual numbers that are following in your notes, so you need to change that because I already printed your notes. So theorem 14, it says two lines intersect to form a linear pair are congruent angles, then the lines are perpendicular. So if you have a linear pair and the angles are congruent, that makes them perpendicular. On theorem 15, if two lines are perpendicular, then their intersections form four right angles. So that makes them be at perpendicular lines, then they have four right angles. On 16, it says if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Okay, so that means we have in this drawing, a little bitty drawing here, it says two sides of two adjacent acute angles. So these are acute angles, and these are the sides, are perpendicular. So in other words, this forms a right angle. Then the lines are perpendicular, or the angles are complementary. Sorry. Theorem 17 says if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So if I have a transversal where it's perpendicular to the first one, then the result is that the transversal will be perpendicular to both lines. So you start with one being perpendicular, the result is both of them are perpendicular. And that's only if these lines are parallel. Theorem number 18, line perpendicular to a transversal theorem, says in a plane if two lines are perpendicular to the same line, then they are parallel. It's kind of like the converse of the previous one. Similar, but you start out with two lines are perpendicular to the same line. So for this little picture, okay, it says that the two lines are perpendicular. The result and if you got all this fancy stuff in here, you have the result is it saying that this line is parallel to this line. And remember, those are arrows inside the lines that show that they're parallel. Okay, on our examples, these are pretty simple looking examples. On one, we have two examples here for part one. It says find the value of x. Notice I have the box, which means this is a 90-degree angle, perpendicular lines, so that means x equals 90 degrees. On the second example, notice we have the box on the left side, so that means these two guys are complementary angles, which mean they add to 90 degrees. That means that's x plus 62 equals 90, so I'm just going to subtract 62 and find out that x is 28 degrees. On example 2, this is one of the more complex ones. It says what is the distance from point A to the line B? Alright, and this is kind of in our essentially question. I want to find the slope of line B, which I'm going to do the rise over run because that's the quickest, fastest way to find your slope. Notice these are the graph is counting by ones, so that would be 1, 2, 3 up and 1 to the right, so my rise over run would be 3 over 1. And I want to find the perpendicular slope. Remember, that is your multiplicative inverse, so I'm going to flip this over and change the sign. Where it's positive, it's now negative. And now I want to use that slope, your perpendicular slope, to meet the line. In other words, I'm going to go from this point, I'm going to follow my slope, which it tells me to go, technically it tells me to go down 1 and right 3, but I'm off the line, so I'm going to do the reversal, which will be up 1 and 1, 2, 3, up 1 and 1, 2, 3. So this produces my perpendicular line. Let me get a ruler. So I can actually draw it. And now it wants to know the distance from A to that line. So it wants to know how long this segment actually is. So what I'm going to do is I'm going to take my two coordinates. And since it wants distance, I'm going to plug it into my distance formula. I don't know if you remember it. Big old long square root. And I have my x2 minus x1 and y2 minus y1 of my points. So if I label my coordinates and plug it in, that will be, what, 7 minus 1 and 4 minus 6. Let me grab my calculator and type it in. Oops, I gotta make that a square button so that I have it typed into my calculator. If I push enter, I get 6.3. So the distance, let me just put AB equals 6.3. Oh, I said AB. A to, I can't do that, sorry. Distance and we don't have any units here, so this is 6.3 units. I guess I could have put A to the line B. Okay. Here is your independent practice problems for you to work on. The first three are like my first example, which they look pretty basic and simple. Then you have number 4, where I'm just having you tell me the distance from H to line J right here. H to J, so we don't need K for this problem. Alright, work those two problems and make sure you enter your summary, and you'll be done for this chapter.